Hello students, today we are going to focus at the phenomena called refraction of light. Bending of a ray of light when it moves from one transparent medium to the other transparent medium is known as refraction of light. We can also define it in a different manner. The change in direction of the path of light when it passes from one transparent medium to another transparent medium is called refraction of light. In your examination, you can write any one of the definitions. And please remember that the refraction of light is essentially a surface phenomena. To show the ray diagrams, for the refraction of light, we have to remember basically 3 points. The first point, when a ray of light travels from a rarer medium to a denser medium, it always bends towards the normal. If you have to draw the ray diagram, have a look. This is the air medium we are taking, which is a rarer medium. Now this is the glass medium, which is a denser medium. So you'll be showing a ray incident obliquely onto the surface of separation. And when this ray is incident, the ray would have gone straight if there would not have been any change in the medium. But because there is a change in the medium from air to glass, the ray of light bends towards the normal. This is the normal I have drawn. So the ray of light is going to bend towards the normal. That means the angle of incidence is greater than the angle of refraction. The angle of incidence is the angle which the incident ray makes with the normal. Whereas the angle of refraction is the angle which the refracted ray makes with the normal. So in this situation, the angle of refraction will be less than the angle of incidence. The second point, if a ray of light travels from a denser medium to a rarer medium, it bends away from the normal. That means the angle of refraction will be greater than the angle of incidence. This we can explain with the help of a diagram. Now focus at the diagram. This is the glass medium, which is a denser medium, and this is a air medium, which is a rarer medium. So when the ray of light is incident on the surface of separation, instead of going straight, the ray is moving away from the normal. That means this is a normal, so ray is moving away from the normal. We can say the ray of light is bending away from the normal. Therefore, the angle of refraction is greater than the angle of incidence. Coming on to the third point. If the ray of light is incident normally on the surface of separation, which means whether the ray is going from rarer to the denser medium or the ray is moving from denser to the rarer medium, any one of the situation, and the ray of light is incident normally to the surface of separation, meaning 90-degree angle the ray is making with the surface of separation. In that case, the ray moves undeviated. There will not be any bending of ray of light. Same in this situation also. When it is moving from denser to the rarer medium, again the ray of light is moving undeviated. Means there is no bending of light will be taking place. Which means angle of incidence will be 0 degree and angle of refraction also will be 0 degree. Now how the angle of incidence is 0 degree? We know the angle of incidence is the angle what the ray of light makes with the normal. Now here the ray is on the normal itself. So the angle which this ray is making is 0 degree. The ray is incident 90 degree to this surface of separation, but it is making angle of incidence as 0 degree. And because there is no refraction taking place, so angle of refraction also is 0 degree. You have to remember here, at the time of refraction of light, there is partial reflection also. But because we are studying in this chapter about the refraction of light, so we are ignoring the reflected rays. We are not showing the reflected rays in this diagram, or while drawing the diagrams, we are not emphasizing on reflection of light. We are only emphasizing on refraction of light. The question arises, what is the cause of refraction? You have to remember that the speed of light is different in different mediums. And this is the basic cause of refraction of light. Now we'll study about the laws of refraction. Refraction of light obeys mainly two laws of refraction. According to the first law, the incident ray, the normal at the point of incidence, and the refracted ray all lie on the same plane. The second law says the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for the pair of media. To represent this, we can easily write it: refractive index of second medium with reference to the first medium is equal to sin I upon sin R. And the constant mu of the second medium with respect to the first medium is called the refractive index of the second medium with respect to the first medium. The second law of refraction is also known as Snell's law. So anytime in your examination, if you are asked to define Snell's law, you'll only write the second law of refraction, not the first law of refraction.